Apple's M1 chip has taken the CPU industry by surprise. How does a low-power, low-performance ARM chip beat the current CPU leader by 2 times in terms of performance per watt? Or consume only 1/3 of the power for the same task? Is this a case of marketing shenanigan, or perhaps telling the truth, but not the whole truth? Multiple independent test sites have reported that the M1 MacBook Pro has a battery life close to the 17 hours of wireless web browsing reported by Apple, beating the comparable Intel and AMD laptops by more than 60%. This magnitude of advancement in a mature product category is rare. Here are some reasons why the Apple M1 laptop is ahead. Reason 1. The 5nm process. We compare the 3 CPU options in the market: Apple M1, AMD Zen 3, and Intel Skylake. By comparing their microprocessor specification, it is clear why the M1 chip is ahead. Using the 5nm process allows Apple M1 to have more transistors, which translate to higher computational power and lower energy consumption. Using a bigger die area also increases the number of transistors. Operating at a lower frequency reduces power consumption. It is clear that Intel's offering is at least 1 to 2 generations behind their competitors. Zen 3 is still the winner in the high-power, high-performance sector. Apart from Intel, who design and manufacture their Skylake chips using their own foundries, most ARM-based chips such as Apple's M1, Qualcomm's Snapdragon 888, AMD's Zen 3, Samsung Exynos 2100, and Google Tensor are designed in-house and mass-produced using contract manufacturers. Most advanced microprocessor chips, 7nm and smaller, are manufactured by TSMC in Taiwan and Samsung in South Korea. Other low-end manufacturers produce chips as large as 200nm. Intel foundries are stumbling at 10nm, and they are subcontracting some 10nm production to their rival TSMC. The cost of manufacturing those 5nm chip is nearly doubled compared to that of the 7nm chip. In short, Apple is offering a state-of-the-art, high-end, low-power chip at a relatively low cost, tailor-made for laptop with battery, size, and weight constraints. Reason 2. Economy of scale. By having a significant share of the market, Apple can reduce their manufacturing cost per unit, offering 5nm chips that are typically used in smartphones rather than laptop CPU. Reason 3. Software and hardware integration. Since Apple designs their own software and hardware, they could optimize both to deliver a more refined product. Unlike the chip companies, Apple does not sell their M1 chip as a standalone, but they offer a completed product within an ecosystem. In the M1 chip, the RAMs are placed beside the M1 chip to achieve lower latency and larger bandwidth. This is not easily achieved by other motherboard manufacturers. Reason 4. ARM architecture. The main difference between an ARM and x86 is that ARM uses a RISC architecture with fixed-length instruction set, while x86 uses a CISC with variable-length instruction set. Basically a reduced instruction set computer versus a complex instruction set computer architecture. In general, the chip with the ability to handle more instruction sets in parallel, with a larger reorder buffer or be ready to assemble partially computed data, have a higher processing power. Reason 5. Specialization. The CPU load is intelligently distributed across the chip, with each specialized chip performing their task more efficiently. Apple M1 has 4 high-power Firestorm CPU cores and 4 high-efficiency Ice Storm cores. In addition, it has a 16-core neural engine dedicated to machine learning and an 8-core GPU. They reduce the CPU workload while enhancing video analysis, voice recognition, and image processing performance. Apple macOS also introduced Universal Apps and Rosetta 2 to allow x86 programs to operate efficiently on the M1 chip. Phone and iPad apps are also portable to the macOS. This level of cross-platform integration and optimization for the M1 chip is not provided by their competitors. Nonetheless, switching between ecosystems, be it from Windows PC to Apple Mac OS or Android OS to iOS, presents a barrier for the users. When it comes to applications that require a powerful PC or a workstation with numerous graphics accelerator cards, the performance of the M1 chip is insufficient. The AMD's N3 chip is still the leader in the PC market.